Okay, welcome to number 5. This one is a little bit of a doozy. It just says simplify. Now, when something says simplify, that generally means that you're probably going to have to factor, especially if it's a rational expression, a fractional expression. So let's just see where we can go with this. X to the negative 1 power, as we discussed on number 1, this is going to be a fraction according to our exponent rules. So x to the negative 1 power is 1 over x to the first power. I'm not going to write that 1 because it's not necessary. And then we have minus x. Now, when we have a fraction subtracting another number, it's helpful to write that number as a fraction because that is going to be the only way that we'll be able to actually subtract these and simplify. So if a number is not listed as a fraction, it's because it is divided by 1. So this is x divided by 1, okay? On the bottom, we have 8x to the 8th plus 8x to the 7th. We're going to take the greatest common factor on the bottom, which is going to be 8. That's our number. And we can factor 7 x's out, so 8x to the 7th. And if we do that, 8x to the 8th divided by 8x to the 7th is just x, because I could multiply that and get right back to 8x to the 8th. 8x to the 7th divided by 8x to the 7th is just 1, okay? So you can always check yourself, make sure you factored your greatest common factor right. If you hippity-hoppity, you should go right back to the original expression. And I find that if I hippity-hoppity this, yes, I will go right back to the original expression. So what we have to do is figure out what's going on up here on the top. Now, I need a common denominator in order to be able to subtract fractions. So I have an x, I have a 1. The easiest way to make this a common denominator is to multiply the top and the bottom of this fraction by x, because 1 times x will be x, and then we'll see that x times x is x squared. So we're going to have 1 over x minus x squared over x, and then we're going to keep the bottom the same. 8x to the 7th times x plus 1. So now that we have the common denominator, we can combine the tops. 1 minus x squared, they are not like terms, so I can't just I can't simplify them up here, but I'm going to go ahead and write them together. And what I want to do is I want to write them in standard form. I want to put my x's before my constants. So this will be negative x squared plus, because it's positive, plus 1 over, the denominator is the same, so we're just going to mix them up. X stays the same, and the bottom is going to stay the same through this part of the problem. Okay, out of room up here. Let's take it down here. Okay. Now, when we write something in standard form, it's generally speaking good practice to make sure that the leading coefficient is positive. So what I'm going to do is I'm going to factor out a negative 1 out of this binomial and see if that helps me out. So negative x squared, and then this will become a negative 1 when we factor out a negative sign. We're still over x, and the bottom is still the same. 8x to the 7th, x plus 1, okay? Now, I see that I have a difference of squares up here on the top. X squared minus 1 is a difference of squares, so that's actually going to factor. I'm going to keep the negative sign on the outside, but x squared minus 1 is actually x plus 1 times x minus 1. And we're still over x. And now that is about as much as I can do with the top. And so now I actually have to go through the simplification process, the division. This is a complex fraction. I know it's not written. We have a fraction divided by a fraction. This does not look like a fraction, but just like I did with this x up here, if something doesn't look like a fraction, you can make it a fraction by putting it over 1. So this is just a very, very fancy way of writing one fraction divided by another fraction. And when we divide fractions, we do what's called keep, change, flip. We multiply by the reciprocal. So this is negative x plus 1 times x minus 1 over x. Instead of dividing by this, we're going to multiply by this fraction flipped upside down. So we'll put the 1 on top, and then we'll have the 8x to the 7th, x plus 1 on the bottom. And now we can simplify this by canceling out something when it's on the top and on the bottom. So I have x plus 1 on the bottom, and I have x plus 1 on the top, so that is going to cancel out. And I don't see anything else that's going to cancel out, so we can start writing our answer. On the top, we have this negative sign times x minus 1 times 1. We can pretty much just ignore the 1 since that's not really doing anything. 1 times anything is itself. So on the top, we've got negative x minus 1. You can distribute that negative sign if you want to. There's not really a point, but it might look nicer to some of you. And then on the bottom, we have x times 8x to the 7th, which is going to be 8x to the 8th. That's supposed to be an 8. My program's glitching a little bit. So this is as simple as we can make the original problem, and therefore this is the answer to number 5. Thank you for watching.